If the n value is 100, then I'm going to have 100 Fibonacci series. So what is Fibonacci series? Here Fibonacci series is nothing but the number series. Now what is temporary variable value? That is A's value, and this indicates that this is the end of my algorithm. Hello to all, a warm welcome to my new session. I am Revati, Faculty, Department of Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today we are on the second session of 5th chapter, and the chapter name is Problem Solving Methodology. Moving further, in my today's session, I'm going to discuss what is algorithm. Along with that, I'm going to discuss some of the algorithm, that is compound interest. That means how to calculate the compound interest, and I'm going to write the algorithm for this problem. Along with that, I'm going to check the greatest of 3 numbers. Along with that, I'm going to discuss factorial of a given number. Along with that, I'm going to discuss what is Fibonacci series and how to write algorithms for Fibonacci series. Before going to start my today's session, let me to recall the things what I had discussed in my previous session. In my previous session, we had discussion regarding introduction about problem solving methodology. Along with that, we had discussion regarding computerized process. Along with that, we had discussion regarding the steps involved in the problem solving process. That means what are the different steps involved in the problem solving process. So here problem solving is nothing but the mental process, and it is mainly used to find the solution for particular problem. Then we had discussion regarding what is problem definition and how to find out the problem definition. Along with that, we had discussion regarding how to analyze the problem, that is problem analysis. Along with that, we had discussion regarding design of solution, and at the end we had discussion regarding characteristics of algorithm. That means what are the different characteristics of algorithm. Moving further, I'm going to have first algorithm, that is compound interest. That means how to find the compound interest and how to write the algorithm for finding compound interest. Before that, let me to explain what is algorithm first. So what is algorithm? Here algorithm is nothing but the step-by-step finite sequence of instruction that is given to your computer system. So these are the step-by-step finite sequence of instruction. So one by one I'm going to give the instruction. That is itself called algorithm. At the beginning I'm going to have compound interest. That means how to calculate compound interest. So this is our real life problem. That means frequently we are going to face this kind of problem. Now I want to write the solution for this problem. Let's see what are the input I required and what is the formula used to find out compound statement. So what's the formula I'm going to have? That is P. So this is the formula actually I'm going to have. That is P 1 plus R divided by 100 to the power N. Now tell me what is P. So here P is nothing but your original amount. So here P stands for principal amount. Then what is R? Here R is nothing but the rate of rate of interest. Then what about n? Here n is nothing but the time period. So here n represents time period. So here the compound interest is our real life problem, and to find the compound interest I'm going to have the formula, that is the actual amount, that is nothing but the principal amount, then 1 plus r. Here r is nothing but the rate of interest, that is in percentage. Now I want to convert it, then I'm going to have the n, that is time period. So this is the actual formula I'm going to use to find compound interest. Then what is the problem statement I'm going to have here? That is, given the principal amount P, rate of interest R, and time period P, this algorithm used to find the compound interest CI. That means CI equal to P 1 plus R divided by 100 to the power n. Now, what is the first step in my algorithm? That is, my algorithm always starts with the first step, that is start step. So what I want to do, before going to start any algorithm, first at the beginning I want to write step 1 is start. That means I'm going to start writing my algorithm. Then what is the next step? That is, I want to identify the input variable. Now tell me, according to this example, which are the input I want to read. That is, here I want to read P value. Along with that, I want to read the rate of interest value. Along with that, I want to read time period. So what are the input I required here? That is P. Then I'm going to have R. Then I'm going to have N. Then tell me, what is the next step I'm going to have? That is, I'm going to calculate the compound interest. So in step 3, I'm going to calculate the compound interest. So what's the formula? That is compound interest, that is CI equal to P, that is nothing but your principal amount. Then why I'm going to write power? Because in computer science we are going to have mathematic function. That means, suppose if I want to write the power of any value with the help of power function, I can able to write. So this power function is always stored under your header file. So I'm going to write the power function. What are the value I'm going to pass here? I'm going to pass 1 plus R divided by 100, n. So instead of writing P of 1 plus R divided by 100 to the power n, I'm going to use this formula. That is P star power of, I'm going to write the mathematical function in order to find the power of n. So which are the value I'm going to pass? That is 1 plus R divided by 100, n. So this actual formula is converted into this form. Moving further, what is my next step? I'm going to print the calculated compound value. So what is my output? That is nothing but the CI. That is print the compound result. Then at the end, I want to end my algorithm. That is the reason I'm going to use exit keyword. That means it is going to illustrate that this is the end of the algorithm, or this is the exit point of the algorithm. So in the compound interest, what are the input I'm going to have? That is nothing but P, R and N. So here P is nothing but your principal amount and R is nothing but rate of interest, where N is nothing but your time period. Then after reading input, what I want to do? I want to find the compound interest for this input. For that reason, I'm going to have the formula, that is P of 1 plus R divided by 100 to the power N. But in computer science, we cannot able to write this formula directly. So what I want to do? I want to represent these formula in the form of machine understandable. So at the beginning, I'm going to write P. Then I'm going to convert, that is, here it is multiplication, right? So I'm going to write star. Then I want to find the power of N. So in computer science, we are going to have the function, power function, used to calculate the power of any given number. So power of 1 plus R divided by 100 comma N. So this is the input I'm going to feed into my algorithm. After finding compound interest, what is my next step? That means I want to display the output. So I'm going to display output of CI, and at the end I'm going to end my algorithm. Moving further, I'm going to have another algorithm, that is greatest of 3 numbers. That means think that I have 3 numbers and I want to find the greatest of given 3 numbers. For example, consider that I have 3 numbers 10, 20 and 30. In the given number, that means in this given series, I want to find the largest of given number. So what is the largest number here? That is 30. So this is the basic calculation. That means in our real time, we are going to use this kind of calculation. Now I want to convert this problem statement into my algorithm. So let's see how I'm going to convert this problem into my algorithm statement. That is, given 3 numbers. What are the numbers I have? Given 3 numbers, that is my input. So what are the input variable I'm going to have here is A. Then I'm going to have B. Then I'm going to have C. So what are the input for this algorithm? That is greatest of 3 numbers, that is A, B and C. This algorithm used to find the greatest and store the result in a variable. That means I'm going to hold one temporary variable to store the value. So along with that, I'm going to have another variable called large. So what are the input I'm going to have here? A and B and C. These are the 3 input variables I'm going to have. Now I'm going to start writing my algorithm. At the beginning, what I want to write? I want to write my first step. So what is the first step I'm going to have? That is start function, or I'm going to give the instruction to my computer system that this is the starting point of algorithm. Then what is my next step? That is step 2. I'm going to read A, B and C, because these 3 are my input value. So these are my 3 input variables. Then what is my third step? That is I'm going to assign a value to large. So here large is nothing but the temporary variable, and I'm going to use temporary variable to store A's value temporarily. Then what is my fourth step? That is I'm going to compare A value with the value B. For example, this is my A. this is my B value and this is my C value. So what actually A holds? Here A holds 10. Then what about B? B equal to 20 and C equal to 30. So according to the sequence of steps, what I have written here, large equal to A. So what now large holds here? Large equal to A. So if A holds the value 10, then the variable large holds the value of A. That is nothing but large value is 10. Now I'm going to compare my B value with A. So here A is nothing but large. So what is my B value here? That is 20. 20 greater than large. So if it is true, then swap the value. That means large equal to B. That means I'm going to assign large equal to B. What is the value B here? It is 20. When I assign B equal to large, then what is the value of large here? That is nothing but 20. And I'm going to end my if statement because this is my comparison. That means I'm going to compare A value with the B value. And if it is true, I'm going to assign B's value to larger and I'm going to end my if statement. Moving further, I'm going to have the next step, that is the fifth step. So here I know A equal to 10, B equal to 20 and C equal to 30. Initially large equal to 10. After my first comparison, large value equal to 20. That means whatever the B value I'm going to have, I'm going to assign to large. So here large equal 20. Now I'm going to compare this large with C value. So I'm going to write the if statement because here I'm going to compare two value. And if I want to compare two value in C++ programming, we are going to have if statement. So I'm going to compare if C value with larger value. That means here what is your C value? That is nothing but 30. 30 is greater than 20. It is true. So what I'm going to do? I'm going to assign C value to large. So now large holds, what's the value? That is 30 and I'm going to end my if statement. After that, what I'm going to do? Here I'm going to print my larger value. That is nothing but output large. That means I'm going to print the largest number. And at the end, I'm going to have step 7 that is mainly used to stop my algorithm. And this indicates that this is the end of my algorithm. So by seeing this, what you can able to understand, these are the step-by-step finite sequence of instruction that is given to your computer system. So these are the step-by-step finite number of instruction. Moving further, I'm going to have another algorithm that is used to find the factorial of a given number. So this is also one of the real-time problem. So how I can able to find the factorial of a given number and what is the formula used to find the factorial of a given number here? That is n factorial equal to n into n minus 1. So this is the actual formula I'm going to have to find the factorial of a given number. So what is the formula I'm going to have here? That is n factorial equal to n into n minus 1. For example, consider here n value is 4. Now, how to find out the factorial of a given number? That is 4 into 3 into 2 into 1. That means each time n is going to decrement by 1. So, this is the actual solution I'm going to have. So, what is the output? I'm going to have 4 into 3, that is 12. 12 into 2, it is 24. So, what is the output I want to get? That is 24. Suppose if I provide n value equal to 4. Suppose if my n value is 5, then what is the output I'm going to have? That is 120. So, this is the actual logic behind to find the factorial of a given number. So, what is the statement I'm going to have here? That is, given a number n, that means I want to read number n from the keyboard, and this algorithm is used to find the factorial of a n and store the result in the variable fact. That means here I am going to design this algorithm is to find the factorial of a given number. After finding factorial of a given number, where I want to store my result with the help of fact variable. And I am going to store my result inside fact. That means here fact is nothing but variable. And this is a sequence of steps involved to find the factorial of a number. For example, at the beginning, I'm going to have 4. Then in my next time, I'm going to have 3. In my next time, 2. And I'm going to have 1. So it is a continuous or repeated process. For that reason, what I'm going to do here, I'm going to use the for loop. So the variable I is, so here I is used to indicate the starting position as the loop counter that varies from 0 to n. That means here I starts from 0 and it's going to end to n. Then I'm going to write my algorithm. What is my first step I'm going to have? That is, I want to start my algorithm. For that reason, I'm going to write my first statement. Then, what I want to read? I want to read the value 4. So, where I can able to read? With the help of variable. What kind of variable? That is of type integer, and the variable name here is n. So, what is the input to my algorithm here? That is n. Then, I am going to initialize fact equal to 1. That means all the results are stored inside the fact. And if I forget to initialize fact equal to 1, then the fact holds some garbage value and you may get some wrong result. In order to avoid that one, I am going to use fact equal to 1. And suppose if I assign fact equal to 0, what is going to happen? Suppose if you multiply any value with 0, you're going to get the product 0. So, in order to avoid that 0, I'm going to assign fact equal to 1. Then, I'm going to write the step 4. That is, compute the factorial by successive multiplication. That means, to find the factorial of a given number, what I want to multiply? I want to multiply each value together. For example, my n value is 4. Initially, I have 4. 4 into 1, it is 4. Then once again 4 into 3. Why it is 3? That is n minus 1. That means each time I'm going to decrement n by 1. So it is 12. Then what is my factorial value? That is 12 into 2. That is 24. And 24 into 1, it is 24. Because I have formula n factorial equal to n into n minus 1. That is 4 into 3 into 2 into 1. So, this is the actual solution I have. Now, I want to convert this real-time solution to my computer understandable form. For that reason, what I will do? I'm going to use fact equal fact into I. That means I'm going to use the for loop because it is a continuous process. That means the same statement is going to execute or repeat 4 times. For that reason, I'm going to write this statement inside my for loop, and my for loop starts from I equal to 0 and I less than n. And I'm going to have the formula fact equal fact into 1. For example, consider what is my n value? N equal to 4. What is my n value here? N equal to 4. And what is my I value? That is I equal to 0. When this condition is true, I'm going to find the factorial of a given number. So initially, what fact holds? That is 1 into 1, I'm going to have 1. According to the example, what is n value? Here, n value is 4 and my for loop starts from 1 to n. That means I equal to 1 and I less than or equal to n. And each time I is going to increment by 1. So initially I is 1 and what is my fact value? Here fact is 1. Fact equal to 1. So 1 into 1, what is the output I'm going to have? That is 1 and which is stored in the fact variable. Now I is incremented by 1. Now I is 2. That is 1 into 2. I'm going to have 2. Now what is my fact value? That is 2. Now I is incremented by 1. Now I is 3. 3 less than or equal to 4. The condition is true. What is going to happen? I'm going to execute this statement. So it is 2 into 3. That is 6. Now what is my fact value? That is 6. Now I is incremented by 1. That is 4 less than or equal to 4. This is true. Now I'm going to multiply 6 with 4. So I'm going to have 24. Now increment I by 1. So what's the value of I? Now it is 5. 5 less than or equal to 4. Condition is true. So I want to repeat this process until the condition is get failed. So how many times I'm going to repeat this statement? 4 times. So instead of writing same statement 4 times, what I will do? I'm going to write that statement inside my for loop. Then at the end, what I want to do? I'm going to print the factorial of a given number. Now where the result is stored? Here the result is stored under fact. Then at the end, I'm going to end my algorithm. So I'm going to write exit, or I can use the word stop my algorithm. This is the way we can able to find the factorial of a given number. Moving further, I'm going to have another algorithm, that is to find the Fibonacci series. So here this is also one of the real-time problem. So what is Fibonacci series? Here Fibonacci series is nothing but the number series, and the number series starts from 0, 1, 1, 2, 3, 5, 8, 13. Now tell me how I can able to generate these kind of numbers. That means at the beginning I'm going to have only two values, that is 0 and 1. So think that this is my first value and this is my second value. Now how I'm going to get third value? That is with the help of first value as well as second value. That means to get my third value, what I will do, I'm going to add these two numbers. That is 0 plus 1. What is the value I'm going to have? That is 1. Suppose if I want to get my fourth number, what I want to do, I'm going to add my second value and third value. That is 1 plus 1, I'm going to have 2. Suppose if I want to get my fifth number, what I will do, I'm going to add third value and fourth value. What is my third value? That is 1. And what is my fourth value? That is 2. That means I'm going to add 1 plus 2, and at the end, what is the result? I'm going to have 3. Then suppose if I want to get my sixth value, what I'm going to do? I'm going to add my fourth value as well as fifth one. So what is the output? I'm going to have 5. So this is the way you can able to generate Fibonacci series. So here Fibonacci series is nothing but the number series that starts from 0 and 1. Suppose if I want to get my third number, what I want to do? I want to add these two to get my third number. Suppose if I want to get my fourth number, I'm going to add my second number and my third number. And if I want to get my fifth number, what I will do? I'm going to add my third number and fourth number together. This is the way you can able to generate Fibonacci series. So first, second and third are the variables. That means I'm going to use how many variables here? That is first, second and third. So here the first term is used to represent first number and the second term is used to represent second number and the third term is used to represent the number of Fibonacci series. That means the total number of Fibonacci series. So here every time first and second terms are added to get my third term. That means I'm going to add first term and second term in order to get my third term, and once again I'm going to add my this second value with my third value in order to get my fourth value. So the actual algorithm starts from step 1. So what is my first step? I'm going to start my algorithm. So this is my starting point. Then what is my next step? That is I'm going to read the input, that is total number of Fibonacci series. So here total number is nothing but n. Then I'm going to initialize the value. That means how the number series starts here. That is 0, 1, 1, 2, 3, 5. So what are the value I required here? To get my third value, I required first value as well as second value. So I'm going to initialize first equal to 0 and second equal to 0. And why I'm going to initialize term equal to 2? Because this is my first number and this is my second number. That means the term is used to indicate that the first two numbers are assigned. That is the reason I'm going to use term equal to 2. That means first number I have 0 and second number I have 1. In order to indicate that one, I'm going to use the word or variable term equal to 2. Then I'm going to add first and second value in order to get my third value. That means 0 plus 1, I'm going to get 1. So initially 1, then I have 1. To get my third value, what I will do? I'm going to add third, that is first plus second equal to third. Now I want to repeat this process for a long time. That means the repetition of this process is completely depends on your n value. Suppose if your n value is 5, that much time I'm going to execute these many statements. So instead of writing for loop, what I have did here, I have taken while loop. So what is the value or condition I'm going to pass here? That is term less than 5. What is the value of term here? That is 2. 2 less than what is n value? That is 5. If 2 less than 5 is true, what I want to do? I'm going to print my third number. So what is the third number? That is 1. Then what I'm going to do? I'm going to swap my actual value. So at the beginning, I'm going to assign what is the value which is stored on second. So what is the value? Second holds. Here second holds 1, right? So here second holds 1. So what I'm going to do? I'm going to assign 1 to first. Then I'm going to assign third to second. That means what is the value of third here? That is 0 plus 1. After adding third holds 1. So what is the third value I have here? That is 1. So 1 plus 1, what I'm going to have? That is 2. Now what I will do? So after adding first and second, I'm going to have 1. And that is stored inside my another variable third. So here what I'm going to do here? I'm going to assign third value, that is 1 to second. After that, what I want to do? I'm going to perform addition operation. That means I'm going to add first value with the second value. Then I'm going to store that one inside my term. Now, what is the value of third? Here, the value of third is 2. That means 1 plus 1, it is 2 and it is stored inside third variable. Now, what I will do? I'm going to increment term by 1. So, what is the value of term here? That is 2. 2 plus 1, it is 3. 3 less than 5, it is true. What I'm going to do? I'm going to print third value. What is the third value here? That is 2. I'm going to print 2. Then once again, I'm going to interchange my value. So what is my second value? That is 1. So that is stored inside first variable. Then whatever the third value I'm going to have, that is stored inside my second variable. So what is the value of third here? That is 2. So 2 plus 1, that is 3, and that is stored inside my third variable 3. and I'm going to increment term by 1. What is the value of term now? It is 4. 4 less than 5, it is true. So what I will do? I'm going to print my third value, that is 3. Then I'm going to swap my value. So what is my second value here? That is 2. Now first holds the value 2 and my third variable holds the value 3. So that is stored inside second variable. Then I'm going to add 2 plus 3 and that is stored inside my third variable. And what's the value? I'm going to have 5 and I'm going to increment term by 1. So what is the value of term? Term is 4. 4 plus 1, that is 5. So 5 less than 5, the condition get failed. So what are the values you're going to have? That is 0, 1, 1, 2 and 3. So you're going to have total 5 numbers. That is 0, 1, 1, 2 and 3. So total, what is the count? 5. So here the for loop is going to execute 3 times, and at the beginning we had printed first value as well as second value. So here the for loop is going to execute 3 times, and here I'm going to assign second and first value. So what's the count here? 2. 2 plus 3, total 5 numbers. That means at the beginning I'm going to display 0 and 1, and after executing my for loop I'm going to have 1, 2 and 3. So how many times the for loop is going to execute here? That is 3 times. And at the end, what I'm going to do? I'm going to end my algorithm. So I'm going to use exit function that indicates that this is the end of my algorithm. So the Fibonacci series is nothing but the number series, and it starts from 0, 1. The third number I'm going to get by adding first and second, that is 1. Now suppose if I want to get my third number, what I want to do? I'm going to add this number and this number. 1 plus 1, it is 2. To get my fourth number, I'm going to add this number and this number. That is 1 plus 2, it is 3. For my next number, I'm going to add this number and this number. So the answer is 5. So this process is going to continue until and unless the condition is get failed. So if the n value is 5, so total 5 numbers you are going to get. If the n value is 100, then I'm going to have 100 Fibonacci series. So dear student, at the beginning we started with finding the compound interest. Then we had discussion regarding how to write a algorithm for finding largest of a given number. Then we had discussion regarding how to write an algorithm to find the factorial of a given number. At the same time, we had discussion regarding how to write the algorithm for finding Fibonacci series or how to generate Fibonacci series. Dear student, let's meet in my next session with some more information about algorithms. Along with that, I'm going to discuss how to draw the flowchart. Until then, keep watching and keep learning. Thank you.